Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the CORS module titled CORS Vulnerability with Trusted and Secure Protocols. Alright, let's get started. This website has an insecure CORS configuration in that it trusts all subdomains regardless of the protocol. So regardless of whether it's HTTPS or HTTP, it trusts it as long as it's a subdomain of the website. To solve the lab, craft some JavaScript that uses CORS to retrieve the administrator's API key and upload the code to your exploit server. The lab is solved when you successfully submit the administrator's API key. So the target goal is the same as the previous two labs, and that's to exploit the CORS misconfiguration to retrieve the administrator's API key. You can log into your own account using the following credentials, and we've got the credentials right over here. So let's right-click on Access the Lab and access it. And we'll also open up Burp Suite Community Edition. Hit OK. At some point, I'm going to have to update this. Let's close it for now, hit next, and start Burp. Okay, go to the proxy tab, set intercept to off, and then click on the HTTP history subtab. Now go to Foxy Proxy extension in your browser and make sure that all requests go to Burp. So now when we hit my account, you should see the request in Burp, and we do, which is good. All right, let's log in with the account that we were given. Hit login. You could see over here we've got the API key of the user and it's displayed in the accounts details page. Now notice, just like all the previous labs, the account details page has a CORS header. So the access control allow credentials header, which means that the application definitely makes use of the CORS protocol. So we have to test it for any CORS vulnerabilities. To do that, let's right click, send to repeater, and go through the test cases that we learned about. So the first one is changing the origin header to an arbitrary value. So let's do that over here. Let's add an origin header. And let's just say https random.com, hit send. We don't get the access control allow origin header, which means that it does not allow any arbitrary origin to access the data of the site. So now let's change that to the null value, which was our second use case over here. Hit send, and we get an internal server error. That's interesting. Now let's do another use case. So let's copy this, put it in here. And the third use case would be change the origin header to the origin of the site, to one that begins with the origin of the site. So in this case, we're keeping the exact origin of the site, except we're adding it as a subdomain to our malicious domain. So if the logic in the backend code that checks if an origin is trusted or not only checks if it's contained in the origin, then this would work. So if we hit send, we also get an internal server error. So that's interesting. Let's go back to just .NET. And actually, let's add HTTPS. I don't know if we're getting the internal server because of this. Okay, so this works. Again, let's test out .malicious.com. Okay, so we were getting the internal server error because we weren't adding HTTPS in the origin header. But now that we do, we get a 200 OK response. But again, the access control allow origin header is not reflected back to us, which means that this test case fails as well. So we're going to move on to the fourth test case, which is change the origin header to one that ends with the origin of the site. So in this case, what we're doing is we're checking if it trusts all subdomains. So let's remove this over here and just say random dot the origin of the site, hit send, and here we go. So we see the access control allow origin header. If we make this a little bit bigger, you could see over here that it trusts the subdomain of the site, which is random dot the origin of the site itself. And what that means is that the application trusts all the subdomains of this domain over here. Now, this could be problematic because if there's a vulnerability in any of your domains, let's say an XSS vulnerability, then you could use that XSS vulnerability to host your malicious script on it and have your malicious script execute from that subdomain in order to retrieve the user's API key. So in this scenario, we're going to have to find a subdomain in the application that contains an XSS vulnerability. And we're not sure if that is actually the case. So let's do some recon on the website. Let's go back to proxy. And the last request over here was number 10. Let's make this small again. And then let's just go to home and review the requests as they go over here. So if we click on view details and we look at host over here, and let's click on check stock. Okay, so this is interesting. Check stock invokes a function that is performed on a subdomain stock.the domain of the site. So here we go. We've got a subdomain. Now let's test to see if this subdomain has an XSS vulnerability. So let's right click this request and send it to repeater. And then in repeater over here, let's send again. Now all it does is it gets the product ID and the store ID, and then it tells you the number of items that are left in stock. So let's first test the product ID parameter to see if it's vulnerable to XSS, and we'll perform a really simple use case. So let's say script alert 1 and end script, hit send. So we get an error. However, notice over here, it never URL encodes our output. So in this case, if you were to do this in the browser, you would actually see a pop-up page that has 1 in it. And to see that, let's right click, show response in browser, hit copy, hit enter, and here we go. So this is how this response looks in the browser. So we definitely have an XSS vulnerability over here, and it's in a subdomain that the application trusts. And so we're going to exploit the XSS vulnerability in order to add our script over here so that when the user clicks on the site, the script executes, it appears as if it's coming from the subdomain, and it extracts the API key of the administrator user and logs it in our web server's logs. And to do that, let's start writing up our script. So let's save this first. And start the script. So we've got an HTML element, body element, and the script element. And we'll start off in a similar way as previous labs, and then we'll tweak it so that it works with the XSS vulnerability. So the first thing to do is to initialize our XML HTTP request object. So XHR is equal to new XML HTTP request. And again, that didn't work out like I wanted it to. Okay, that looks good. And then we need our URL. And we can get that from over here. So it was the first tab, and it's this one over here. So let's copy that and move this to this side. So it was HTTPS. Okay, and then we're going to perform a GET request. And it's being performed on the URL of the application plus the account details page. And the reason we say the accounts details page, because it's a page that is vulnerable and that contains the API key. And again, we're going to use the with credentials property in order to tell the browser to send the user's cookies with this request. Now, if access control allow credentials was not set to true, the browser will reject this request. However, because it's set to true and we're requesting it in our script, it'll send the user's session cookie alongside the request when the user clicks on the website. Okay, next we send the request. Okay, this looks good. Next, what we need to do is extract the API key from the response of the request. So we're going to say on ready state change, perform this function over here. So we're going to say if the ready state is equal to done, then fetch the response of the request. And the way we're going to do that is we're going to first add a string just like we did in the previous labs, and add the response in the logs of our malicious server. Okay, so this looks good. This is exactly similar to lab number 1 and lab number 2. If you try to run this on its own, it won't work because the application will view it as coming from your malicious server, and the application only allows scripts that are being run from subdomains of the original site or the parent site. And so we need a way in order to put this script in the XSS vulnerability that is available in the product ID parameter. So what we're going to do is we're going to say document.location is equal to HTTP, and we'll take the host from over here. Let's copy this. And again, notice over here, it's on HTTP and not on HTTPS, which is a vulnerability on its own. And then we're going to add this over here. So let's copy this. So the product ID is equal to this script over here. So we're going to add another script tag. And this script tag is for this entire script over here. And we're going to end it right over here. Okay. So we're going to assume, and we'll fix this in a bit, we're going to assume this entire thing goes in here. And then we need to call the rest of the URL, which is the store ID. So we're going to copy that and put it right over here. And close off our document.location. Now this is not being highlighted right because obviously we've got a bunch of spaces and probably characters that don't URL encode properly, and we're going to have to fix that right now. So we need this to be a one-liner just like this over here was a one-liner. So let's start fixing that. So let's take this over here. Again, remove the spaces for this one as well. So far, so good. And let's add semicolons. Now, I believe the plus character has to be URL encoded. Let's just confirm that. So plus, and then right click. And convert selection URL, and then URL encode, and it does. So I'm just going to add the URL encoded version of it. So let's copy this and put it in here. Okay, so far so good. Let's remove the spaces on this one. And this one as well. Again, the plus sign over here has to be URL encoded as well. Okay, this looks good. Now we might need to URL encode other characters, but we'll see. If it doesn't work, then we'll start debugging which characters need URL encoding. All right, this looks good. So what we're going to do is we're going to host this script on our malicious exploit server. When the user visits the exploit server, what the script is doing is it's exploiting an XSS vulnerability in the product ID parameter in the stock subdomain in order to invoke a request from this subdomain that extracts the API key of the user. So let's see if this works. Let's save it first, copy it, go to our exploit server, go down, go to the body element, store the exploit, deliver it to the victim user, and then view the access logs to see if the exploit worked. Okay, so it doesn't look like the exploit worked because, as you can see over here, we don't get the API key of the administrator user. So something went wrong. So let's go back to exploit server and click on view exploit and see the HTTP history. Okay, so it says over here document.location is equal to this, but it doesn't look like it's actually making that request, which means that we have something incorrect in our code. I wonder if we right click and then inspect element and look at the console if we could see what's wrong. Okay, so over here it says there's an uncaught syntax error, and it says the literal is not terminated before the end of the script. So something's wrong with our script. My guess is it has nothing to do with the single quotes or the double quotes, but the fact that you need to URL encode some of these variables. And I think you do need to URL encode this one over here. So let's do %3c to URL encode it. Now let's see if that works. So let's save it, copy it, go back to the exploit server, let's close these two, paste it in here, again, store exploit, deliver the exploit to victim, and then access log, and it's still not working. So there's still something wrong with our script. Okay, and I think I know what's wrong. The reason it's not logging in the web server is because you actually have to specify the entire URL over here, considering that it's within another script. So let's go to our exploit server and get the exploit server URL, put it in here, hit save, and I think it should work this time around. So if we copy this again, paste it, store exploit, and this is how real life testing works. Sometimes it doesn't work and you have to debug it. So click on deliver exploit to victim, and then access log, go down, and here we go. Okay, so it wasn't logging because you needed to specify the exact URL of the exploit server. So if you look over here, the administrator clicked on the link and you were able to extract the API key of the administrator. So let's copy that and submit the solution. Here we go. It says, congratulations, you solved the lab. Okay, so we successfully completed the exercise by exploiting an XSS vulnerability in a subdomain of the application in order to exploit the CORS vulnerability in the parent domain of the application. So in this scenario, we used an exploit server where we hosted the script, and then the administrator clicked on the link and the script ran, and it exploited the two vulnerabilities. Now in a real world scenario, you need to host your own exploit server, and that's what we're going to do next. If you would like to see a detailed version of the video where we host the script on our own web server, check out the video linked on the screen. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you, and see you in the next video.